Okay, so I present about opportunities in Asia with recovered carbon black and tire pyrolysis oil. My main activity is in carbon materials, including carbon black, but also, of course, recovered carbon black, graphenes, and nanotubes. I'm the co-founder with Smithers of the Recovered Carbon Black conferences, and we'll tell you the story in a moment. And what I also do, and what is really a passion of mine, is reporting about the carbon black industry and the recovered carbon black industry on social media like LinkedIn and YouTube. I've seen now in China it's not blocked anymore. The last time I was in China, it was blocked and I had to use a VPN. So I think it helps that our industry, when I say our industry, I mean carbon black industry, recovered carbon black industry, even the tire industry is not super active on social media. So that is my passion. Now, this picture is taken in Düsseldorf 2018 and at the Carbon Black World Conference of Smithers. And you can see me in the middle and after the workshop about recovered carbon black. Now let's go back a little bit. Where was the carbon black industry at that moment? That moment, actually, the carbon black industry did not want to hear about recovered carbon black. There was only one presentation allowed, and that presentation was Peter de Haar together with me, and but Smithers offered me to do a workshop, and in that workshop, there were quite a few people. But first, let's ask ourselves the question, why didn't like the carbon black industry, recovered carbon black back then? We need to go back a little bit further to around 2011, 2012, and there was a terrible shortness. I don't know if anybody remembers the shortness in 2011, 2012. We had the rebound from the recession, and of course the demand rebounded quicker than the supply. So there was a shortness of product. I was working in the carbon black industry in that moment, and actually I tested in our recovered carbon black, which proved to be really appalling quality. But it was in that time and during the shortness that many recovered carbon black companies were founded and they brought materials on the market. Now they don't have the experience yet that we have nowadays. They didn't have the test methods, the ASTM group was not founded, so they sent their black stuff to the carbon black people, and the carbon black people, they were just fed up with all these poor, it wasn't even recovered carbon black, let's call it just carbon. So that was the reason why we could only have one presentation in 2018. Now let's step forward a little bit. Because the workshop was such a success, we founded the Recovered Carbon Black Conference in Europe, in Berlin. And here you can see François Masson from Michelin. So I think it's very good karma when Michelin does the keynote in the inaugural conference, because as you can see in this picture, last year in Barcelona, we had 388 delegates in the conference, so it was a huge success. And there was almost every carbon black maker, every tire maker, many recovered carbon black producers, equipment producers. So that was really building a big community. And this is where we are now, where carbon black producers work together with recovered carbon black producers. So let's move on to my agenda. First of all, you know, we've really did a deep dive already on recovered carbon black, but I want to get two basics on recovered carbon black and pyrolysis out of the way. I want to compare numbers of end-of-life tires in the West and the East. I will look at the Western perspective, which is pretty much my work, my day-to-day work, working in Europe or with US companies or maybe with Japanese companies, not so much with Indian, Chinese companies. And then the Eastern perspective. I will give you some learnings, recommendations, underline the role of the recovered carbon black, the role of the tire pyrolysis oil, and really to preempt, these are Siamese twins. So it is not quite sustainable to only sell the one or the other. We have to market both of them. I ask my question very often because I'm very analytic. Are there any growth limits to the industry? Like, you know, now we are just starting and I'm already thinking, okay, where's the limit? Where can it go in 10 years, 20 years, 30 years? Where is the distant future? And then what can help us to grow the industry? So recovered carbon black and pyrolysis basics. So you can see the tires, obviously, we're converting the tires with a thermal process. I say rubber granulates because for me, whole tires in batch process have very limited use and are not really upscalable. So you have an inert atmosphere that is typically nitrogen. There are some processes that work with steam as the inert gas. And some work with steam and go back to nitrogen. As far as temperatures, they're very low temperatures. Maybe too low is 350, maybe too high, getting already into gasification is 1,000 degrees. I think 500-600 degrees is a good temperature. Also, we have to keep in mind, if you want to drive off the polycyclic aromatic hydrocarbons, some of them have a pretty high boiling point, as high as 700 degrees. And then we need to work both with temperature and pressure to get them off the recovered carbon black. An interesting thing few people talk about, I've seen one mention about energy use, and I found that very interesting today. I think that was the EcoStar presentation. The theoretical value you need for the pyrolysis of a typical rubber granulate with a little bit of water, 1% water and 1% steel, is about 356 kilowatt hours per ton of granulate. Of course, real-life processes have a certain efficiency, which is not 100%. So we see efficiencies of 80%, 84% in that range, and corresponding higher energy use. I think nowadays we have such a plethora of technologies. Once they are industrialized, of course, we will see how energy efficient they are, because it's not really the capital expenditure that is problematic for business. It is when you have higher operational expenditure. And the energy use is one of them, of course, in the pyrolysis. Then typical mass balance, 10% gas, 50% oil, 40% rCB, that is your mass balance. Of course, I put it in very fine print. You can read it on the PDF, and I'm not going to read this. Of course, this is a very simplified mass balance. You will have some waste. You will have gas scrubber waste. You will have sludge. You will have C5, C6. You need to take off the gas in order to go into your burners. That's like a WOX fraction. So there's many more fractions than just the big mass balance. But the two major products, of course, are the oil and the recovered carbon black. Now, one thing which is close to my heart is recovered carbon black is an engineered product. It's made on purpose for an application. And when we look at the composition of recovered carbon black, it's a mixture of carbon blacks plus some inorganic material, plus some organic volatiles, plus some solid volatiles, carbonaceous residues, or coke, or charcoal. It was mentioned in the previous presentation. So the first two, the mixture of the carbon blacks and the inorganic content, depend on our choice of the tires. So we absolutely have to control what we put into the pyrolysis. Otherwise, we cannot expect a stable outcome of the pyrolysis. The two other properties, the volatiles and the coke, or the carbonaceous solid residues, they depend on our conditions in the pyrolysis. So it's really very important for me to say, recovered carbon black is not the solid that comes out of every tire pyrolysis process. No, you need to control the process, and the process starts before the pyrolysis with the choice of the tires. So these are pretty old numbers, but sourcing end-of-life tires, I found out that, at least in Europe, these supply chains are incredibly conservative. So they change very, very slowly. So they're almost 10 years old. 2015, India one is from 2017. I really like the data from the Tyre Industry Project commissioned by Deloitte for the World Business Council for Sustainable Development. They have 2 reports, and they give you an idea of what countries all over the world do with end-of-life tires. And I won't go through all the numbers. I highlighted in yellow some interesting bits. Western perspective, USA, 45% energy. The US actually is championing in civil engineering use, so use of tires in civil construction. And so chopped up asphalt, or even as bales used in construction. In Europe, you have pretty much half of it is mechanical and half is energy use, and most of the energy use is cement kilns. In Germany, even 2 closed cement kilns were reopened because they can take whole tires. And it's not a bad history, really, because in a cement kiln, you have 75% energy use, but you have 25% material recycling, because the metal and the inorganics, they stay in the cement. Now, when we go to China, first of all, China is big in everything China does. Generally, every product in the world, China has at least half of the world production capacity. And with tires, it's very big. So the end-of-life tires were reported by the CTRA at 10 million. About a third of it is reclaim. So this is chemical recycling by breaking sulfur bonds, hopefully only sulfur bonds, not so much the polymer backchain. 11% pyrolysis, which is much more in Europe. In Europe and US, it's below 1%. And the below 1%, that is the reported number. So there's a reporting threshold under 1%, nothing is reported. The actual capacity in Europe is actually higher. The actual capacity in Europe could be over 1%, but these are operations that are not full-scale operating, demonstration plants that don't run 24/7. India, similar picture, high recovery rate, 30% reclaim, even more pyrolysis than China, 28% pyrolysis. I think that is very important to keep in mind when we compare the East and the West, and we ask ourselves, what can we learn from each other, the East from the West and the West from the East. Now, the Western perspective is really what drives the business is 3 things. The content of circular materials, the content of renewable materials, and the low greenhouse gas emissions that is used in the production of these products, but also that these products provide. Of course, and we've seen this in the past presentations, we know all recycled materials where you put 1% of the recycled material and you lose 1% of the property. That, of course, is not of interest to tire makers and the rubber industry. Unfortunately, and which is really limiting the growth in Europe, we have a very high complexity and high barriers to entry, starting with a high capex. So when I talk with Asian consulting clients and ask them about their budget for a tire pyrolysis operation, usually they wouldn't buy a European technology because it's 10 times more expensive. Permitting is very difficult in Europe, and one particular challenge to the permitting is pyrolysis is so small, so there is no permitting category in the countries for pyrolysis. So pyrolysis is put into the incineration category, depending on the scale, small incineration or a big incineration, and you have to get corresponding permits. Product regulatory things, you have all heard of REACH. In the US, it's the Toxic Substances Control Act. It's the same thing. And it's a tedious procedure. Good news is, of course, recovered carbon black now has a REACH number, and so it can be attributed to that REACH number. Also, the typical question of investors in Europe is, do you have everything pre-sold? Now, some people have managed to do that. For example, Circtec, they have managed to do that. Scandinavian Envirosystems, they've managed to pre-contract even the recovered carbon black, which normally I would say is very, very difficult, almost impossible, because the tire makers, they give the product approval, but they don't give the factory approval if you don't have the factory yet. So rCB product development is still key to the projects, because, I mean, even in Europe, there is tire pyrolysis operations that do nothing with the carbon. But you cannot beat the mass balance. You cannot forsake 40% of your output, because when you look at your revenue streams, it is your mass output times the price you get. If you don't commercialize one output, you have zero. You might even have a negative price. You might have a liability to get rid of your carbon if you don't valorize it. And the upscale, if you do refine the carbon, is almost 20-fold in value from the thermal value. Investors remain cautious in Europe. Unfortunately, now good news is this year we see some traction. We see some even major scale investments, and the investors are starting to understand and warming up with the industry. What is the Eastern perspective? Eastern, and the map is also a very old map. I couldn't find beautiful China anymore. It was a big project, also 100,000 tons announced in China. Of course, we know Double Star is now, the Double Star project is the EcoStar operation. There used to be a big operation from NewTek, and the NewTek friends are here in the conference, in the fair. Takes then 200,000 tons. So pretty big projects, which is quite unique. And we haven't seen anything like that in Europe. There's one plant, the Circtec plant, now going forward in Delfzijl in the Netherlands, which aims at, in phase 2, going at that size. We have a lower complexity in Asia, low barriers to entry. You buy a kiln and you're in business. Of course, it's not quite as easy, but in many locations, it is pretty much like that. China, India, Pakistan, each of these countries have hundreds of pyrolysis recycling operations. China, of course, the one question I ask always myself, even with furnace carbon black, China has a humongous capacity and is still adding carbon black capacity, but the use rate, the occupancy of that capacity is lower than in Europe. In Europe and the Western world, typically a furnace carbon black plant would run at 80%. If it needs to, maybe at 90%, because if it runs at 100, then things break. However, the use rate of the furnace capacity in China is around 40%, so it's much lower than the 80%. Generally, what I see, apart from big companies, the small companies, they have not developed the recovered carbon black yet, so they don't have done the deep processing. What is interesting, and we get the same in India as well, there's a lot of companies that just sell the oil. In India, there's a pretty good, attractive price for the oil. There are now companies popping up that are only refining. They take the raw recovered carbon black from other companies, refine it, and then bring it into the market. Then, of course, the question is, you cannot just mill and pelletize, because then you need to intake a low volatile content raw material. And if people don't valorize the recovered carbon black, they don't make sure that there's no organic volatiles. So a robust refining process would start with a second pyrolysis to get rid of the organic volatiles, then milling, and then pelletizing. And of course, that is costly. And of course, that is expending energy. One big topic, of course, is the import of Western end-of-life tires to India, which is coming to a stop, which is already banned, but the tires still find the way to India with different custom codes or as chips, because the recycling industry in India is that big, and they have that, that kind of feedstock requirements. What are some of the learnings? So one thing is certainly coming from Europe, and I think what I heard only this morning, I think there's the same efforts in China as well and in Asia, is industry collaboration, is collaboration on standards, collaboration on regulation. have a joint voice, because in Europe, it's so complex. And if the companies don't work together and they don't have a strong voice to get everything done. Ecosystems, so we all know the Michelin ecosystem black cycle. This was pretty much a half academic ecosystem to show the possibility of what we can do when we work alongside the supply chain with several companies. But there's a big scope, and the success of black cycle, we can see that it was copied. Now we have a Korean black cycle, and with similar companies, polymer companies, rCB company, tire company, refinery. So the principle is very successful. One other success from Europe, Bridgestone, a big tire maker, Eni, Italian refinery, and a Portuguese tire pyrolysis company, BB&G. They work together also for an ecosystem to recycle tires into tires, and the pyrolysis oil is used to make SBR. I haven't seen that so much here in the presentations. I have the impression that the petrochemical use of tire pyrolysis oil maybe is not that developed or that much of interest, rather the carbon black production. Now, it takes incredible time to develop the supply chains. And when we put ourselves in the shoes of a tire maker, next to the risk of the product and the risk of the company, if there's no supply chain, it's very, very difficult for a tire maker to get intake, to intake that product. So tire industry supply chains, they need to be built over years and years. And you know, when we talk about supply chain, it's upstream and downstream. So actually, for the big projects, if you have a project for 200,000 tons of tires, it's quite difficult to get that amount of tires because the tires are not all in one place. And of course, the supply chain is also for the products. ASTM standards are super important, both for recovered carbon black and TPO. And one thing, you know, one reason the capex in Europe is so high, first of all, we have high cost of labor, high cost of energy, high cost of everything. But when you start with a very small operation, your first operation will be very expensive in the capex. Once you copy and paste and you have the 10th facility, then of course your capex will come down. What is the role of recovered carbon black? Now, recovered carbon black, I call it the money maker. It is 40% of the mass balance, roundabout, depending on the temperature and process, but it can be 60% of the revenue. So very often when we have a one-stage pyrolysis, and I didn't hear that either, I heard people talking about whether it's good to have batch or continuous. That is not the question I'm asking. I'm asking the question, do you have a one-step process or a multiple-step process? Because if you have a one-step process, it really is difficult. You have to decide, should the oil be good or should the recovered carbon black be good? You don't have the flexibility to get both good. So a multiple-step process helps in that regard. The tire industry loves recovered carbon black. They're quite strict and they don't find the quality, but 7 out of 11 global tire makers, representing 65% of the tire production, prefer recovered carbon black over reclaim or even a mechanical rubber powder. Ongoing standardization, of course, and grading efforts, I find it very important to have recovered carbon black grades. The commoditization will help its market introduction. And of course, the business model, if you don't have grades of recovered carbon black, we're in a specialty business. We need to make to order, and we need to make to a certain customer specification, which is not what the carbon black industry does. The carbon black industry makes to stock, makes defined products and then puts it into stock. So that's a totally different business model. Tire pyrolysis oil, I have only a couple of minutes left. I won't go through all of this, but it's 100% recycled. It can have a renewable content, 30 to 50%. It can have low-ish sulfur, but typically it has high sulfur of 2%. And of course, the obvious application scenario is as a fuel or as a diesel blend stock, as a carbon black blend stock. But in Europe, we see very popular by BASF as mass balance blend stock for the chemical industry for the production of polyamides or other polymers. Growth limits. On the chart, you see what I call the carbon map. And I have mapped for clients all carbon materials, including nano materials, which I don't include there. But you see price against volume. The biggest commodity on Earth is coal. And you can see it's humongous. It's a really big volume. This is a double logarithmic chart. The point I want to make, mascara is a very small market and a very expensive product. The ladies among you will know mascara is about $1,000 per kilogram. Of course, carbon black is not that expensive. Recovered carbon black is not that expensive. The point I'm making is and tires, if you take all tires, I'm estimating 50 million tons per year. If you pyrolyze all those tires and the half is oil, we're still many magnitudes far away from the crude. So really, we have to be very selective where we put the oil. And of course, being selective is going for high-value applications into material valorization rather than as a fuel. Limited feedstock, we have that already in Europe. We have 3.5 million tons of tires, but it's very difficult to source the tires. Lack of education, many pyrolysis companies, they are developing their machine. They don't really know how rubber works. Lack of standards, grading was mentioned, permitting governance complexity. What helps us in the growth? Industry growth, of course, the stronger voice with peer collaboration, synergy with tire industry, creating ecosystems, industry education and product standardization. So I think that is really key for the small startups to learn what does a tire company expect? How is a tire built? That kind of education. Also, not neglectable, the technology is nice, but we are humans. We make business from human to human. So building over long years a good relationship with your customers, your suppliers, the whole value chain is very important. And what I see here is great. We have a full conference, and I think this is a very good starting point for building an Asian community for recovered carbon black and tire pyrolysis oil. Thank you very much. Any questions?
Thank you, Martin. Wonderful presentation. Just a quick question. If you think about the fact that we cannot beat the mass balance, as you said, there are limitations to the feedstock, which is a big part of the quality. What are the parameters that one can control or manipulate in the process to achieve some differentiation in quality? Because right now it seems like pyrolysis is quite common, and it's very hard to understand how can one company differentiate their rCB from the other.
I mean, what you control, and what I mentioned, what you control anyway is the temperature and the residence time in your kiln. However, as I mentioned, if you have a one-step process, you need to make a decision. Do you want to have a good oil? Do you want to have a good carbon? Because the process conditions for both might be different. So hence, maybe double-stage process, it's expensive, but companies that have auger kilns is much easier with an auger kiln than with a rotary kiln. Blackberg Carbon in Netherlands has done it with a rotary kiln. But you know, the big thing I don't even see European people doing at length yet is controlling the tire feedstock. And you know, that is on a very simple scale is, you know, you don't take any tire and put it in the process, but you group the tires according to their chemical composition. And the first one is, you know, truck tires and car tires. Maybe use truck tires to reduce the ash content of your recovered carbon black. But it goes further. You know, there are companies that now can identify the type of the end-of-life tire, and they can say, this one is a Michelin winter tire, this format, and then In the future, the hope is that there will be databases built up of very rough TGA data, like how much ash content, how much carbon, and that then we can sort the tires by detecting these tires, by knowing the rough composition, and having even, the variation going into chemical variation going into pyrolysis even smaller.
Thank you.
Any more question? Over there. Thank you.
Thank you. Do you know any other oil refineries and petrochemical using TPO as crude oil or naphtha?
Well, the thing is, I can only talk what is in the public domain. Of course, I'm working with companies, but I cannot disclose them. But also, well, public is INI, public is BASF, and the many carbon black producers like Tokai Carbon, Cabot, Orion, for example. They all take a TPO or refined versions of TPO. But other refineries, sorry, I cannot say. Thank you very much. Thank you very much. So we are concluding the session.